where work has me. And so it's almost, it's 8 p.m. here now. So a little later than most folks on the call, but I know we got everybody joining from all over the place, which is great. So what I'm going to do is sort of go through what is in essence a new tool that we've built. But I'm going to go through the methodology that we went through to build this tool so that you can understand how the pieces go together and you can implement some of these same things yourself if you don't want to go to a vendor for a tool. But the cool thing is we have this tool available. So if you guys want to take a look at it, that would be, really great. So we're going to look at your API footprint. So what are we going to talk about today? Well, mostly visibility and API security. Risks associated with the exposed resources that you might have out there. And then we'll do a little demo and I'll kind of put all of these little pieces together. And then at the end, we'll have time for some questions and answers. And if I can't get to your question, we'll forward that stuff back to you so that way we can get answers. I'm just going to check in real quick to make sure that everybody can hear me and stuff. And I don't see anybody complaining and saying they can't, so looks like we can. So my name is Jason Kent. I'm the hacker in residence here at Cequence Security. I've been working on application security and application security related things for about the last 20 years. I've spent the last about 10 looking at APIs. My first responsible disclosure that I had was on a Chamberlain garage door opener API, which I was able to open my garage and I was able to open a friend of mine's garage, which led me to the conclusion that I could open all garages that had this thing. We did a responsible disclosure, they fixed it. And I've done various responsible disclosures, and I'll talk about a few of those as I go along over the years. The company that I work for is called Cequence Security. We're the API security platform that has a prevention first approach. We actually built our mitigation technologies way before we built any of the discovery technologies that we have. And so as we've gone through the development cycles and through the time that we've been out, the solutions that we've been developing have allowed for us to not only mitigate threats, but find new ways to apply security and compliance to APIs and find those APIs that are out there. APIs are now really the core of everything that we see anymore. Employee applications, microservices that are developed for all sorts of different issues, and applications out on things like mobile devices. APIs are moving data around all the time. My brother-in-law just recently bought a Tesla, and he was showing me some of the neat features that he has just from his phone that the car will react to. And he and I were having this conversation. And I said, you realize how complex this is, right? You say, I want my heater to turn on and I want the car to be 1 degree warmer. That transaction gets sent up to the cloud. The cloud then has to talk to the car. There's authentication pieces that go on inside of both of those transactions. All this data is handled securely, et cetera, et cetera, et cetera. All these APIs are moving data around all the time. And so it has become kind of this natural progression for us to move toward APIs. And a lot of that started with, the advent of mobile apps and understanding that there are APIs that are out there. About 80% of the traffic that we block at our customers is coming through APIs. So think about that for a second. About 80% of the traffic that's handled by the organizations that we protect is malicious traffic, and it's traffic that's attacking their API infrastructure. So being there, being able to set in place some policies and block this stuff is really important. And it doesn't matter if this is that north-south traffic where it's your customers communicating directly to you, or that east-west traffic where you're moving data back and forth or requesting things from databases. APIs really are that thing, right? That are enabling us to do lots. And in fact, almost every organization today that has decided, okay, we're going to buy a tool or we're going to implement a system, has a conversation with that vendor that says, what kind of APIs do you have? And, can I control this through an API? Rarely do we want to go work with dashboards. We want to work in single systems and have all that communication work seamlessly. There's been lots of breaches around APIs. I just have a few listed here. That one in the center, log4j, that actual vulnerable component inside of Java caused a lot of problems, and we saw lots of API traffic. But if you go around the horn here, you can see some of the people that have made the news. Peloton, in order to make the news, the researcher actually had to go find someone that was using Peloton that was a reporter and tell them their data, right? If you think about the case of John Deere is a really great example of why it's good to know where your development environments are and what sort of data they hold, because inside of those development environments, a lot of times development staff or the operations staff will say, we need a accurate database to go up against here, so why don't we just copy the production one? And that kind of thing can lead to a breach in the dev area that can actually lead to learning about internal things that you don't want. In this case, the developer was able to look up every piece of equipment that farmers owned, who those farmers were, where they were, and lots of information around all of that. It doesn't seem like they had anything malicious in mind. It's just they could see this stuff and knew it was bad. There's a couple others out here. My favorite one on here is kind of the smallest logo, and that's Brewdog. Somebody took a look at their application, realized that there was a broken object level authorization problem inside of it, and started generating coupons so they could drink free beer. Everybody likes free beer. Even if you don't drink beer, free beer seems like a great idea. So APIs are impacting all of these organizations because they're really the tool of choice for developers. They're making it so much easier to just write a little small front end and then have all the data transmit back and forth. And that's actually the work that the application is doing, rather than trying to generate all the HTML, JavaScript, style sheets, and all of that kind of stuff. In the app world, I already have a field for that. I've figured that out already. I just need to populate the data. But what's coming along with this is we're seeing more and more off-the-shelf solutions that get purchased. And we're seeing more and more things like health monitoring APIs that are out there for those systems, which have a lot of interesting data in them. Sometimes it's error messages, sometimes it's, more than that. Things like open API specs are things that, for a long time, the security teams have been saying, listen, we need a way to understand what's supposed to be in this application. How's it supposed to be architected? And each one of these endpoints, are they supposed to be authenticated, not authenticated to get here? How's that supposed to work? So we'll dig into a few of these things, and I'll talk about how you can instrument yourself to go look for them in your own environment. APIs are obviously a huge target for malicious use, not only sensitive data and looking at customer data on the back end, but also things like account takeovers. I've noticed that in some of the tools research that I do, I've seen like attackers say, all right, well, what you got to do is go to this API endpoint, authenticate, and the session token that you're going to get off that API endpoint, you can then use in another API endpoint or another transaction or even on the web. And that's like a super token. And so people learn how these things work, and they're constantly spending time banging away on the APIs to try to figure out, can I get into this environment? And if I can, what can I do when I get there? Content scraping is huge. I've been working with our customers here in Paris and all over the world, talking about content scraping and how it's impacting them. It depends on what it is that you do for a living and what your organization does. But you think about it, finding hotel room rates is a competitive advantage if you're, somebody like Kayak or somebody like Expedia, sorry, if you're somebody like a travel agency or something like that. So content scraping is starting to see more and more utilization out there. And malicious traffic related to anything has increased. But as we know, with the conflict with Russia and Ukraine, we're seeing just massive amounts of traffic hitting API endpoints that are either originating from Russia or they're originating from Ukraine. Obviously, geographical location and geographical shutdown is one of those things that you'd like to do. In my opinion, I think that every packet that comes from Russia should be sent right back. But those are, things that you can do with a solution that's trying to mitigate some of these problems. The very first step in all of this, and the reason that we're even talking about it, is because we need visibility. We need to understand what's out there. What is connected to my domain? And that could be a million different things, right? There's probably websites out there. Maybe there's API endpoints out there. Maybe there's email, right? We have to figure out what are the different things that are plugged into our environment. And then do they have APIs on them? And this is where it becomes a little bit more tricky, right? I can look at things like subdomains, and I could read the subdomains and maybe infer, hey, there's an API endpoint here. But really, in order to understand, is that true? I may have to take a couple of extra steps. And we'll talk about some of those steps and things that you can do. Once you have an understanding of, yes, I have APIs out here, then what you're going to want to do is look at the APIs and figure out, do I have vulnerabilities inside of this? Is there something that is increasing my risk profile just simply because I have these APIs? And then doing that in an ongoing basis is something that a lot of our clients really came to us for. They wanted to be able to say, this transaction that just went through, was that a legitimate transaction, or was that somebody attacking me? Or they may be looking at it from the perspective of, did the application behave correctly? Publish an API spec, we'll look at the spec, we'll see transactions happen, and we'll say, hey, this endpoint doesn't appear on the spec, or this endpoint is supposed to be authenticated, but we're seeing unauthenticated transactions, people that aren't authenticated in the workflows here. And then the last thing that you want to be able to do is shut down anything that's out there. A lot of what happens in the web security world is, somebody like me will stand up on stage and go, geez, these developers are screwing this all up. And that's not always the case. Sometimes it's operations, sometimes it's business logic. And what has happened is something that was developed correctly. It just has a flaw in it, and there's some kind of flaw that we need to fix. No matter where you sit in this, you're going to have to figure out, is somebody attacking me in that flow? Is somebody doing something they shouldn't be doing in that flow? And we can help with that in real time, as well as help you with policies to do things like mitigation temporarily while the application gets fixed. We used to label as virtual patching, but that really sounds like I'm just going to block bad traffic. And it could very well be that the traffic seems legitimate. It's just at a certain rate it isn't, or some other aspect to it. And we can tune to those things and block those attacks. So if you're thinking about your attack surface area, what all are the things that are plugged into me and publicly available? This sort of runs down all of those pieces. And I'm going to break a lot of these out, and I'm going to talk about them in greater detail because it's warranted, and it's something that you guys probably ought to think about. But realistically, the very first thing on here is the very first thing that most of our clients get excited about when they run the tools. How many APIs do you have? That's a question that seems like it's really easy, but let me ask a different question that leads the same way. How many web applications do you have? I've been asking that question of enterprises for the last I don't know, 15, 20 years. We've been building tools for vendors for a long time. And what I end up with when I ask that question is one of two camps. One is, we don't know, help us find them. And the other one is, here's the spreadsheet of 9,000 applications we maintain and we update it every day. Now, the first case is the large majority. If I go to 10,000 customers, I'm going to get that 9,998 times. That latter case is one where this is an organization that has a maturity model that's not meeting the market. They're far ahead of everybody else, and having that list really helps them. If you think about why it's important to know number of APIs, where they are, how they're plugged in, that kind of thing, just look to the other side of this, and you'll see unpatched log4j apps. Log4j was a huge problem because I could just simply swap out a user agent or anything that you're logging, and I could get it to fire. Spring4Shell now, right? We've got a new one that came down the line. When I talk about inventory, oftentimes I talk about things like vulnerabilities, because being able to find them and patch them is going to be an activity that you're going to have to undergo if you have these problems. So if you already have a list of the applications, it's pretty easy to test them. It's pretty easy to patch them. So let's go through a few of these things and we'll talk about it a little bit. That first thing, knowing which APIs you had, which endpoints you have, where they are, all that kind of stuff. There's some old ways that we used to do this. Last summer, I taught a class for OWASP on how to take apart APK files to find API endpoints in them. So these are Android mobile app files. You rip them open and you can find all of the API endpoints that the app is going to talk to. And there's a bunch of great information in there about how the application works. My first way that I ever broke an API apart, when I broke into the Chamberlain APIs, I did that through reverse proxy. I just simply set up Burp Suite on my laptop. I told it to listen on a port, and I'd listen on all interfaces. And then I took my mobile app or my mobile phone and I connected it to the Wi-Fi, proxying through Burp Suite on my laptop. This only works if you don't have certificates pinned. And sometimes you can get it to work if certificates are pinned, but it's a lot harder to manage. If you can reverse proxy, then you can see all the transactions and you can see what needs to make things happen, right? So in my garage door example, there was just a condition value that said set the condition to 0 or 1, 0 being closed, 1 being open. We could look at traffic in line sometimes. It just really depends on how the environment is set up and what things are going around and what access you have. But there's some new ways to kind of figure this out. I want to give a shout out here to the folks that did Kite Runner. If you go look for Security B-Sides and Kite Runner in Google, you're going to see some really interesting stuff. And this is all stuff that is the sort of the open source way of doing this. But they talk about application routes quite a bit inside of this. And we're seeing more and more organizations that are trying to get an understanding of how all this stuff works. They're doing things like open API specs because they have to have an API spec to make their security tools work. If you're running Qualys web scanning and you have an API, you've got to have some file that tells it where the endpoints are, or the scanner can't figure out how to get to things. Scanning old websites was easy because there was always links that took you back home or took you to the login page, took you around. You could just read the links. APIs don't work that way. But the other thing, and this is really the thing that Kite Runner kind of exposed, is common endpoint enumeration. Where are the API endpoints that you might have? So we often see, a API layout that's like v1/login or API/v1/login. And then we see v2, and then we see v3 as the app gets built. what we're going to do is look for V1 and V2 and V3. If you're on V16, I want to know if those early ones were available. In addition to that, things like GraphQL have very common endpoint naming standards. API specs have common naming standards. So common endpoint enumeration actually will get you pretty far when you're looking for things inside of APIs. One of the things that we help you with is finding your non-production servers, and we do this through various public records means as well as some inference scanning. But basically, we want to find out is your development environment online? Is everything working? And if it is that your intention? Do you want that to be there? Development, staging, QA, call it whatever you'd like. Do you want those pre-production environments sitting out on the internet? And if you do, which is fine, how are you protecting them? One of the things that we worry about is that, you're going to go copy production into dev so that way everything looks normal. But the other thing is just being on your dev environment, I might be there just to learn something, like how something works. And so having your pre-production environments be out there and available for everybody isn't necessarily the greatest plan, right? I often advocate for taking those environments and sticking them inside of your inner VPN environment. So I have to be on the VPN to reach those things. And I think that's a great idea. That helps you gauge who's going to be there. It helps you gate anybody that's coming on to this. But oftentimes, business is going to be done in such a way that that's not going to be practical. For instance, if you're opening your platform for someone else to develop on it, you may not be able to, stick it behind a VPN. If you're trying to be very public about the way the application works, you want somebody to write development stuff for you, then you're probably going to have trouble with that. But think about that for a second. You can have that environment by itself and protect everything else. Policies can be applied per environment rather than a blanket policy that says got to be public or not public. Open API specs are a really nice gateway into applications. They tell you everything about the application that you want to know. We used to call them Swagger files. It's not called Swagger anymore. It's called Open API now. But really, I can use Swagger specs to help me, or Open API specs to help me find endpoints. I can figure out whether that endpoint needs to be authenticated, how many of them are out there. I can look for all kinds of markers inside these specs. Do I need to be an admin to see this endpoint, etc. And so what we often say is you need to generate an Open API spec because developers, tools, other folks are going to need this thing, and that's fine. Having it listed publicly and having it available publicly attached to the application that it's defining may not be the best policy or process that you could implement. And what I mean by that is if I go pull the spec down, if I know you have an application that exists at example.com, I can put in /swagger.json and I might get the Swagger file, the Open API spec file that comes back off of it. So oftentimes these things are used, like I said, for tools. And in fact, we use them for one of our tools, but sharing them should be one of those things that's like under NDA, let's get you a copy of that after you've signed these things kind of deal. We use the Open API spec to do inline compliance monitoring. So if the spec says this particular endpoint is supposed to have only a certain data flow on it, or can't have PII on it, or whatever that might be, we will then compare the traffic that goes against that endpoint to the spec and see, are you complying or not complying? And is there something wrong that's allowing for that compliance to be broken? GraphQL. So this is one of those things where GraphQL has very common endpoints. They're either at /GraphQL or /API/GraphQL. We find them in those locations all the time. There's a GraphQL cheat sheet that OWASP puts out to help you with any kind of security concern that you might have with GraphQL. But think about this for a second. A lot of this stuff is being controlled by JSON requests, and it sends back JSON objects. And being able to sit in there and just make those requests it's kind of a bad idea. I can pull data and see the graph data that may come off of it. But also, this allows for you to very quickly and very simply shift a lot of data. And so I can make a single request that dumps everything. And that could be, a really bad deal. So going out and looking, are these endpoints out there is something that everybody should probably be doing, and is definitely one of those things that, I recommend for everybody as we move toward the future. Login endpoints. This is one of those things that, it seems like, well, why do I care? I know it has login. Why would I care? But keep in mind, login endpoints are going to change over time. And what they can do will change over time. So it could very well be that in version 16 of the application, authentication works completely differently than in version 1. But if the version 1 endpoint's still on and all of the code's still there and all of that still works, which is, by the way, usually done for legacy reasons, sometimes the authentication there is a little more, let's call it lax. Or the error messaging there might be a little more lax, right? Error, this is a bad user. Error, this is a bad password. I just recently did a responsible disclosure with a camera company that made a very small camera that you could put in a child's bedroom if you want to monitor a baby. I actually used it out of my greenhouse. Something was eating my cucumbers, and so I stuck the camera out there. I bought the camera, I put it out there, and while I was waiting for the thing to come eat my cucumbers so I could get a picture of it, I started looking at authenticating into the camera with all my traffic going through Burp Suite. And what I'd found was an old endpoint that would say error bad username if I put the wrong username, and it would say error bad password if I had a correct username and a bad password. So think about the implication there. If I wanted to test to see if a group of usernames and passwords worked in this environment, it would be very easy for me to write a little small Python script that would just iterate through sending those requests in. I could pull everything out of a database. It really wouldn't take that long. The error messages are going to tell me if accounts exist. The error messages are going to tell me if the passwords are good or bad. So you think, well, yeah, you can automate that and make that pretty easy. But think about this also. Websites, when you go to a web www.example.com/login and you type in a username and you type in a password, there's all kinds of stuff that's sitting on that page that could be watching and protecting that page. It's also going to do things like slow you down because you got to, put things in very specific places. Against APIs, however, this is computer to computer communication, and it's intended to be that way. I can run through a list of usernames and passwords at very high speed, at computer speed, in fact. And this will allow for me to not only understand that I have connected to this API and done, as much as I can, but it'll also let me understand who can log into this thing at a very high rate of speed. And think about it for a second. Once you learn what the passwords are, what do you want to do there? Because you can run that at computer speed too. So account takeover attacks against platforms like this are far easier if the error messages are supporting them. I opened a responsible disclosure with these guys. They went ahead and fixed that error messaging, so that way it's very confusing. And so, yes, you have to figure out what you did wrong. Did you type your username wrong, or did you type your password wrong? The error message doesn't really support or help you anymore, but it also doesn't support or help the attacker. Health monitoring endpoints are really interesting in that a lot of times they'll tell me, is this server on? But sometimes they actually generate a file and respond back with that file to tell me that the server's on or that it has certain conditions met or is of a certain health state or whatever that is, right? Sometimes they come across as 2xx, 4xx, 5xx, but they have data associated with them. So if you're looking at a health monitoring endpoint and you're wondering, what's on here, or what can I do here? Just start banging on it and try to get it to generate some error messages. Oftentimes, these are the helpful ones, right? Like Matthew Broderick said in War Games, sometimes the thing is so confusing that you have to ask it questions so it can help you. And so here we are sitting in front of a bunch of health monitoring endpoints. What can we do with that? Well, the ones that generate files are great DDoS examples, right? I make the server have to create the file and send it to me. It's a very small file, but that doesn't matter. That's a process that still has to happen on the server. And if I attack fast enough and I do enough things, then I can end up with a bunch of data coming back to me. I can also enumerate services here. If anybody's running Mailgun in their environment and you have an API endpoint on email.yourenvironment.com or whatever, you're going to see Mailgun respond. And it responds back with a little bit of text, but it actually tells you this is Mailgun. And is that good or bad? Yes. It could be a good thing for if you're monitoring to see if Mailgun's online. It could be a bad thing if suddenly they have a vulnerability or there's something that I can go after. And if I know you have Mailgun, then I'm going to go after it. You got to remember, recon always works, right? And it's one of those things that you're trying to minimize as much as possible. The last thing that I've been covering with a lot of my clients is exposed files, and you'd be surprised at how many trust stores we find out there. There's P12 files that are all over the place. And I got to questioning, like, why are there so many of these things happening and why are there so many out there? And then I ran across a mobile app API endpoint that had a P12 file on it, and it clicked. In order to pin a cert, you have to send the cert to the app. But what happens if the cert expires? Well, we'll just put the new cert in a place that it can be downloaded from the public internet. Okay, so that works okay with public keys because they're supposed to be distributed. But then when you dig into the folders that these are sitting on, usually the private keys are sitting there. And so that's not something that you want, and it's something that you should be monitoring for. In addition to this, we see things like directories and executable files. There's all kinds of stuff that are sitting out on these servers that are public. You definitely want to monitor for it, and you definitely want to shut it down when you find it. I'm still seeing lots of known vulnerabilities for Log4j. We're still seeing it out there for financials. We're seeing it for telcos. We're seeing it for retailers, for healthcare. And now Spring for Shell is out there. We're going to see vulnerabilities over and over and over again. Having an API inventory means you can go fix them. If we look at how many of the financial institutions are out there that have Log4j on them, it's a pretty high number. 60% of American banks, the top 10 banks in America, I literally Googled top 10 banks in America and went and looked for Log4j on them. We're still seeing it out there. Why is that important, or why does it matter? Well, this is a really bad vulnerability, and it calls out to whatever service that you have associated. So what I'm seeing is DNS queries coming back from these organizations. If I had malware executables tied to the end of that, insert shenanigans here, it would be fun. So we've been looking at, all these different things in your attack surface area, but you can understand now why looking at your API attack surface area really makes it so that you can figure out what an attacker sees. They see simplified attacks. They see unprotected shadow APIs. They see specs that tell them what it is that they can do. You'll see sensitive data exposure on a lot of these things. And when you start to really look at the error messages and the messaging that's coming back off these endpoints, oftentimes you start to see, wow, I really can do something with this API here. And that's what an attacker is going to do. It's there, it's on, you're telling me about it. That keeps me around much longer, unlike completely secured unknown APIs where, you know, I'm basically going to be rattling a locked door and not really getting anywhere with that. Do you still have Log4j or Log4Shell vulnerability in your environment that can be seen from the public? This is something that, you know, you might want to get into. I'm about to drop some information on what I'm calling long Log4j or Long4j. I don't know, marketing's probably going to change it. But what we're seeing is some of your downstream systems also have this vulnerability. And the way that you test them is you have to wait. So you send a request into your server that is going to call back to a known DNS entry. So that way you can see the unique request sent to the server and you can see the DNS request come back. And then you wait a couple days. And oftentimes after 24 hours, the logs will be shifted from your application to an analytics service, and that analytics service has the vulnerability and will fire another request. Stay tuned for that. I'm going to be dropping some a blog post and a threat report and much longer information about it. So if you want to start testing for that, that's literally how you do it. Or we've got a solution that might be able to help you out. Financial services are still dealing with this problem. Like I said, 6 out of the 10 are still having at least one server unpatched. And I'd be willing to bet that a lot of the time it's this analytics workflow that I was talking about that's causing this problem. But banks notoriously have a lot of applications. So they are going to obviously have the deepest well to go diving in. So there's some risk profiles associated with these different issues that I've been talking about. And a lot of times when you talk about something with a security professional, everything sounds bad, right? Oh, you know that I have login endpoints. Well, that's terrible, you know. Not everything is bad. Some of it's just simply information. But you have to remember in information security and cybersecurity, you have to add things up in a very kind of odd way. 2 low severity things, 2 2s, can often equal a high severity thing, which is a 5. 2 plus 2 can end up being 5. Now, that's typically only true for very large values of 2, but vulnerabilities can become very large values very easily. So realistically, the high severity issues, the things that you're going to be really concerned about are things like exposed files, logins that have some kind of problem with them. And oftentimes API login is done through a key. Those keys aren't traded very often. Maybe the key's the same. Maybe the key's not even needed. We've tested several sites where I've erased the key and just put nulls in or put 1 in place of an entire key and it works. Things like exposed origins and error messages, those are going to be higher severity issues. Your medium severity issues are things like your health and metrics endpoints that are accepting requests and providing back data. That's possible denial of service there. Swagger specs could be a medium severity issue, but they also could be a high severity issue. It really depends on what's in them. On the low severity end, this is more informational. Yeah, I've got an endpoint out there. Maybe it's got an exception that's not working correctly. Maybe there's some GraphQL on it. Maybe there's a login, right? But you notice some of those things belong in the high severity issues. It's contextually driven. And so it really is going to matter how this impacts your environment when you start to think about it. As I said before, we built our solution as a defense solution first. Then we started to add in detection inside of that and now discovery. And so what we're going to talk about is our API Spider solution. We're going to look at what you can do with API Spider. I invite you guys to come and ask us for access to this tool so that you can go look at it. If you don't want to use a tool, I've given you a few things to help you along the way so that you can perform some of these tests on your own. And so what I'm going to do now is simply log into the solution and I'm going to go searching for our domain. So here is the information that has come back from the scan that I ran. There's lots of information listed here, and it probably makes a lot of sense now, the things that I covered in the slides, because they're all sort of here on the cards in the dashboard. So you can see we've got a couple of things that are highlighted inside of here. This red thing right here telling me that we've got log4j on one of our endpoints. I also, when I logged into this solution and ran this scan, it emailed me and told me, hey, you've got this bad thing that's out there. When it's a high severity issue, it's something that you want to know about right away. This allows for you to do that. In addition to that, just that first step that I talked about where you want an inventory, you want to know what are the endpoints that are out there. But we layer on top of that, where do you host these endpoints? So that way you can take a look and see, oh, these are coming from all these different places. And then kind of break things down. So if you decided, for instance, that you needed to move a server or an application from one environment to another, you could easily look that thing up here and figure out which environment that it's sitting in. So we've got our inventory together. We know what's out there, and inside of that, now we can start pulling together all the information that we've been talking about. So I can find my login endpoints. I can find my Swagger endpoints. I can see where exceptions are happening, where I might have SSL servers that have bad certs, and all of those sorts of things. One of the things that I love about this is being able to pull out all of my non-production servers and being able to find out which QA and dev environments are out there. A lot of times our developers will have to stand a system up to run a test. And this actually helps us understand that that system came online, and then we can look at it and say, you know, is this needed still? So we can use this in combination with, we use AWS internally. We can use this in combination with our AWS dashboards to understand where systems can be shut down and which systems may need addressed in some way. The last piece that I'm going to sort of discuss here is just simply, when we look at this data, we want to cut it apart. So these cards actually let us do that. So we can, you know, click on it and it'll show, you know, what data is associated with those things, including the high severity stuff. Also tells us where the app was tested. So we can have an understanding of which endpoint that this came out on. We see it's happening on every endpoint for this application. And we can also see, you know, more realistically, did the app behave correctly? It give me a 200, did it give me a 500? Those sorts of things. Are there false positives in this? Absolutely. We leaned on the side of find it and try to tell you that it's there. And what we're doing now is we're in the middle of dev effort to grind all of that stuff out. So this is kind of a beta environment still, but it does help a lot of our customers get lined up with, what do I have out there? Where is it? Is there anything that I should be concerned with immediately? And for a few of our customers, we've actually found Log4j in places they didn't know they had it. We've found login endpoints to systems that should not be listed on the internet. We've found myriads of bad SSL because most dev environments don't get set up operationally with good certs until they enter production. We've found GraphQL endpoints at many of our customers. And finally, like I said before, we found trust stores that were online and that actually contained private certificates inside of them. And that's a pretty nasty scenario if you're trying to protect things. And so it definitely is one of those things that you should be taking a look at this data and trying to understand, is this happening to me? Is it out there? And is it something that I need to be worried about? So I invite you guys to take a look at this solution. If there's something that we can help you with, it definitely is something that we'd love to talk to you about. There's some consideration for external versus internal monitoring. What I'm showing you is the external monitoring. We're looking at public information. We're looking at the actual endpoints that we can reach from the internet. But inside your environments, we also have solutions that can look at whatever's happening in your environment. So when you're only looking from the outside, what's available is discoverable to you. So what is listed in some public database somewhere. But when we look internally, what is actually happening is discoverable. So we can see what endpoints are people touching, which ones are the endpoints that they touch the most, touch the least, where can we make changes? If you make changes to infrastructure, that kind of lights up on that external monitoring, but internal monitoring lets you see changes in behavior. It lets you know that people are pivoting to a different user agent or that they're trying different things in order to get in. Usually operationally, you're talking about configuration errors, something that needs to be changed in configuration. It's not necessarily always true, but usually when you're talking about internal things, you're talking about maybe coding errors or something that dev can go correct, as they go through their cycles. So we have this API Spider solution. We also have an API Sentinel. That's that internal view. So once we have a good understanding what's outside, we start to look inside. And then that final step in this is to go for mitigation. But being able to assess and remediate is something that everybody desires and is something that everybody wants. What we like for people to do is go to cequence.ai/demo and sign up for a demo. But if you go to apispider.cequence.ai, there's a page that you can actually request access to the solution. It's not automatic. We actually gate this. Somebody on the back end has to approve you. And the reason that we do that is just simply because we don't want to give a whole bunch of people access to this thing and then they go off and scan their bank or their insurance companies or credit cards, and they end up making a bunch of people mad about it. We deal with complaints. When we scan somebody, we get complaints sometimes. But a lot of the stuff that we're doing is simply public record lookup, so they don't even know that we're doing it. It's when we do something like a log4j scan or something where we're actually trying to test vulnerabilities that, it's more like rattling the doorknobs and trying to test the windows. So if you want to sign up for this, you can. We're happy to have you, get a login for it, run it, and find some value out of the solution. And I hope that you're able to do so. I'm right at the end of my time now. And so I'm going to stop sharing and probably drop out into the chat. It's 8:59 in my time. I think it's 1:59 for you guys. I'm seeing a couple of questions in here, and I'll address them real quickly. Are we seeing incidents because they don't follow zero trust principles? No, usually we see incidents not because they're not following some kind of principle or whatever. It's just simply a mistake was made, and either coding needs to happen or something like that. Business logic abuse in things like for things like BOLA and error messages, IDOR, that kind of stuff. That's that internal look. That's where you're going to actually see those abuses happening. We see that a lot. And in fact, we have mitigation techniques for a lot of those kinds of things. Can you feed the tool an open API 3 spec and get information back? Absolutely. We'll tell you where the transactions are missing the spec. And in fact, the internal tool that we have will help you generate the specs if you need. So I'm at my 50 minutes, and I think that my time is now up. So I really appreciate you being here with me. I appreciate everybody that attended. And if you're watching this through recording, I hope you're having a great day and that everybody keeps smiling. Thanks for your time.